What if pen test results arrived the moment they mattered, not weeks after the damage was already done? Picture this. You wait 2 weeks for a pen test PDF. You open it, copy findings into Jira, and chase teams on Slack. Context is gone. Tickets are generic. Engineers are already fixing other fires. That old document-first model treats security like a snapshot while your systems sprint forward. It worked for annual audits, not continuous delivery. So how do you flip delivery from slow photo to live feed where fixes start immediately? A static report is a photo of a moving train. It captures a moment, but misses everything that comes next. Teams ship code hourly. Cloud assets appear and disappear. A PDF dated yesterday can already be irrelevant. That mismatch creates delays, lost context, and mounting security debt. The real cost isn't the report. It's the time between finding and fixing. So what shifts are forcing us away from snapshots toward continuous delivery? 2 big shifts changed everything. First, teams test more often. Releases happen hourly, not quarterly. Second, tool chains multiply. Scanners, cloud checks, SAST, DAST, and manual pen tests all emit findings. That doubles down on volume and velocity. When your attack surface expands by the hour, manual handoffs break. So why exactly do these 2 shifts demand automation? Let's unpack them one at a time. First shift, testing frequency. Development cycles move to continuous delivery. Security teams adopt CTEM, continuous threat exposure management. That means vulnerabilities must be found and prioritized continuously. Waiting for a consolidated report is a luxury no one has. Tests run alongside releases. So how do you deliver findings while scanning continues, without overwhelming teams? Second shift, a fire hose of findings. Scanners like Tenable and Qualys, cloud posture tools like Wiz, SaaS tools, and manual pen tests all generate issues. Without a central plan, teams drown in duplicates and noise. The coordination overhead becomes crushing. So automation isn't just convenience, it's triage at scale. But what does that actually look like in practice? Automation changes delivery from batched reports to real-time workflows. Findings route to the right owner instantly. Tickets generate with required fields. Retests trigger the moment a fix is submitted. That reduces the time between discovery and validation dramatically. Automation also embeds testers and engineers into a shared workflow, so closure is a process, not paperwork. Next, we'll break this down into 5 essential components you can implement starting today. Component 1, centralized data ingestion. Pull every finding into a single system. Scanners, cloud platforms, SAST, manual notes. Normalize fields like severity, asset metadata and tags, deduplicate entries and enrich with context. Without centralization, vulnerability management becomes stitched spreadsheets and guesswork. With it, you get a reliable single source of truth that lets automation make consistent decisions. What comes next builds on that tidy backbone. Component 2, automated real-time delivery. As soon as a finding is confirmed, deliver it where work happens. Create or update tickets, attach evidence and reproducible steps. Notify the precise Slack channel or mailing list. This lets testing and remediation run in parallel instead of in sequence. You move from waiting for the final PDF to acting while tests still run. But rules are necessary. That's where routing comes in. Component 3, automated routing and ticketing. Define rules by severity, asset owner, environment, or compliance scope. Automations assign owners, populate Jira or ServiceNow fields, and set SLAs. Tie rules to threat intel for known exploited vulnerabilities. Integrations with common platforms make this practical. Done well, routing reduces manual triage and ensures the right team acts fast. But speed without standards causes chaos, which leads to the 4th component. Component 4, standardized remediation workflows. Every finding follows a defined lifecycle: detected, triaged, in progress, ready for retest, closed. Specify required evidence for closure. Align severity scales and capture risk acceptances. This reduces confusion and supports audits. Standardization also powers metrics and dashboards. When every ticket follows the same path, you can measure delays and improve them. But closure isn't real until validation occurs, which is our 5th component. Component 5. Triggered retesting and validation. When a ticket moves to ready for retest, automation assigns a tester or triggers a QA pipeline. Require concrete evidence on pass or fail. Attach artifacts directly to the ticket. Auto-update dashboards and SLA metrics based on results. This closes the loop and prevents the classic fixed-in-code trap. With these 5 components, you move from reactive firefighting to predictable closure. But how does this flow feel in a real example? Example, discovery. A tester finds an IDOR in a critical web app. They document repro steps and attach proof of concept screenshots. The finding enters the central system and gets normalized. Metadata tags the asset as production and critical. That metadata will drive routing and SLAs. Now the system decides where the issue goes and how fast it must be addressed. What happens the moment that rule fires? Real-time delivery and triage. An automation rule detects severity and TADs. The system auto-creates a Jira ticket in the AppSec project, populates fields, and assigns it to the app team. A Slack message posts to a narrowly scoped channel with evidence and a link. Engineers get actionable details immediately. Triage happens fast because the ticket already contains context. The dev team can start a fix even while pen testers continue exploring related endpoints. What does remediation look like next? Remediation and retest. Devs ship a patch referencing the ticket ID. CI/CD pipelines reflect the change. When the ticket moves to ready for retest, automation assigns verification back to a tester. The tester reruns the exploit steps, attaches results, and marks the issue closed if fixed. Dashboards update automatically. MTTR, closure rates, and SLA adherence refresh for leadership. Quick recap: centralized ingestion, instant routing, standardized workflows, and triggered retests create a rhythm that shrinks exposure windows dramatically. Metrics matter. Track MTTR by severity, MTTFA from delivery to first action, handoff delays, retest completion times, and percentage of findings assigned within 24 hours. Also monitor reopened rates and duplicate reduction after normalization. Those numbers prove whether automation reduced exposure or just shuffled tickets faster. Want a concrete ROI example? Keep listening. The next stat will surprise you. A real example. Reducing MTTR for exploitable criticals from 21 days to 7 days shrinks the exposure window by 2 weeks. That's not just faster reporting, it's fewer opportunities for attackers. Fewer Sev1 incidents mean less firefighting, lower insurance risk, and better audit outcomes. Tie these improvements to business outcomes, and automation becomes a measurable reduction in risk, not just a fancy integration exercise. But beware, automation also has pitfalls. Avoid common pitfalls. Don't automate everything at once. Start small with high-impact slices. Don't treat automation as set and forget. Review rules quarterly. Map ownership and workflows before you automate, or you amplify chaos. Minimize alert fatigue by notifying only those who can act, and include change management so developers adopt the new flow. These traps derail many programs, but a phased, feedback-driven approach keeps momentum. Ready to start? Here's a pragmatic 30-60-90 plan. Start simple. Day 30. Pilot 1 domain and 2 product teams. Automate delivery and ticket creation. Day 60. Add retest automation and SLA tracking. Expand to 4 teams. Day 90. Onboard cloud and infra findings and publish executive dashboards. Define your data model first. Build routing rules for criticals and iterate. Pilot, measure, adjust, then scale. This approach balances quick wins with durable process change. Choosing tools matters too. What should you look for? Tooling checklist. Must-have integrations with scanners and ticketing systems, normalization, deduplication, rules engines, RBAC, evidence support, SLA tracking, and retest automation. Prefer strong APIs and webhooks. Nice-to-haves include combined risk scoring, compliance mapping, and threat intel embedding. Also weigh data residency and SSO. Security and compliance tie into design. Log every state change. Use least privilege, and protect sensitive evidence. Finally, think beyond today. What's the future of pentest delivery? The future is continuous, not episodic. Pentests will blend with purple teaming, attack surface monitoring, and bug bounties into a constant stream. Delivery becomes event-driven. Findings appear, route, get fixed, and validate without manual batching. Automation makes security an operational rhythm, not a backlogged project. Start with a narrow scope, measure outcomes, iterate rules, and embed retest automation. The payoff is shorter MTTR, cleaner audits, and a security program that keeps pace with your delivery pipeline. If this helped, like and subscribe for more tactical security workflows. And tell us in the comments which part of your pen test process needs automation first.